Hi everyone. Next we move on the next topic, common drain amplifier. Name itself says this is a common drain. So drain is a grounded portion, and in this portion we have gate as a input and source as a output. Because of the source output, it is also known as a source follower. Why? Because the source whatever we are getting in a output portion and gate is a input. So it's source follower amplifier, also another name for the common drain amplifier. So how circuit look like? Usually we have to take as it is first one particular AC signal. For that we have one RSIG, and common drain means the gate is input, so connected to gate input, and we have source is one resistance. We can call it as a RL or RS, whatever you can name it. I am calling RL. Why? Because it is a output load resistance. So here it is connected as a output portion. Okay, so what about drain? Drain is actually common drain means drain is common, so connected to drain here. So this is your V0, this is RL, and this is RSIG, and this is what your V. So this is how the common drain amplifier circuit look like. The thing you have to remember that drain you have to make it ground, and the output you are taken from the source. This is the source, and as usual gate is the input. Now in this, how to convert into the small signal model? First we are converting into the small signal model. Always remember that small signal model there is a two type. So first model we have as a pi model or hybrid pi model. So if it is yes, source is connected to ground, then we can go with the pi model. But in our case source is not connected to ground, so we can move, and the another method is called pi model. So first convert into the pi model. What you will get usually, the first as it is the gate portion is as it is here. Then we are getting as a from the drain there is a current, so that current we are calling as a ID. So that current is coming, and after that we have one resistance for the source, that is called 1 by Gm. Okay, so this portion is source, this portion is drain, this portion is gate. This is the diagram for the your MOSFET if source is not grounded. So this is what we are taken. So from this circuit, after that we will make as a the other things, what are the connected part. So here connected part we have V in, so go with the V in, and before that we have RSIG, connect RSIG as it is, and here positive and negative we have V in. Okay, so this is how connected, and connected to this portion, connected to below here, and this source is connected one more resistance called RL. So this is nothing but source. Okay, this portion is nothing but this portion. Okay, then RL, then this is connected here, and drain is this portion connected to directly the grounding part. Okay, so output we are taking from source to grounding portion. This is nothing but V0. This is the small signal model for the source follower or common drain amplifier. From this, again we have to find three things. The first thing we have to find is Rin. Already we discussed, if it is the gate is your input and you are discussing about Rin, Ig is always 0. So Rin is nothing but RSIG is nothing but we can call as a infinity. This is similar to the previous method, source method. Now we can move on the next step called as a R0. Now it is very important how to find R0. R0 can be obtained. We have to make such a arrangement that input side we have to make 0. So R0 can be obtained making V in is 0. That means previous all those stuff, these are actually not shown because R0 can be easily done with the portions. But here R0 we have 1 by Gm and RL both we have. So R0 always can be obtained from when you make V in is 0. When you make V in 0, that means this portion here, whatever you connected, it's look like a 1 by Gm is there. Then you have RL is there. So actually in this side we have the input portion is something present V in, but when you are taking R0 output resistance, always making input is 0 or input is not connected. So what happens? The input is when you are making 0, then it is connected to ground and it look like this. So for this circuit, this is the equivalent of the R0. So when you look like this, the R0 is a equivalent of these two resistance, and one point is connected here and another point is also connected to ground, each 2 point. So it look like a parallel. So very important. Usually all the people will do the mistake here. It is look like a 1 by GM RL series when you are taking from with respect to V0, but always R0 can be obtained. You have to make input portion is 0. We are only dealing with the R0, only dealing with the output. So only consider output. Input portion we have to vanish. So that reason we will get R0 is equal to 1 by GM parallel to the RL. This is the one more very important relation for the R0. And usually what actually the thing is here, the RL is usually very high, so you can ignore it and you can take R0 is almost equal to the 1 by GM also. This can also be written how we are written previously, small R0 ignore, like that. Similar way you can take it, because RL is much greater than 1 by GM. If you want, you can consider this relation or keep it the above relation only. Okay, so this is all about R0, how can be obtained. Next, third one, very important, how to find gain. So gain finding, we know that it is nothing but V0 by Vi. So first we consider how to find V0. So look at the circuit here. When you are getting V0, it is something like, it is coming from here, then we have one resistance, this resistance known as 1 by GM, and then we have one more resistance RL, and it is connected to ground here. Okay, so this is ground and we are taking output V0 here, and whatever we are giving from this is V. Okay, now again look like this circuit, what it look like. Again it look like a your voltage divider bias. So you have to apply voltage divider bias rules to here. So V0 is equal to, V0 we are taken with respect to RL. So take RL resistance divided by total resistance 1 by GM plus RL into the given is input signal. So it is V. So this is how we got as a V0. Once you know how to get V0, so the similar way you can get as a AV. So AV is nothing but V0 by Vi. So can I write AV is equal to V0 divided by Vi, and V0 is RL divided by 1 plus GM plus RL into Vin. Divided by Vin means, can I cancel Vin both the side? So the final answer we can write RL divided by 1 by GM plus RL. This is the one more very important relation for AV what we got. So AV can be called as RL divided by 1 by GM plus RL. This is the formula for AV for particular common drain amplifier. Remember all the configuration, almost Rn and R0 we can easily find out, but AV when you are finding, you have to go with this V0 and Vi. Here V0 we are going with the voltage divider rule. Previously you remember that common source with source resistance, we went with the input as a voltage divider rule. Here it is opposite, it is voltage divider rule in the output side, because source is connected this side. Okay, so now for this reason you have to apply the voltage divider rule, and when you simplify with that, you are getting as a AV something like that.